To solve for x here, we want to combine our logarithms as much as possible. So here, for part A, we just combine these. We're subtracting the logarithms, which means we divide on the inside. So this is x over 5. Now I have a single logarithm equal to 2, so I can write this in exponential form. The base on this log is base 10. So if I take that base and raise it to the 2, then I set it equal to that, x over 5. Well, that's 100 equals x over 5. Multiply both sides by 5, and that gives us x. X is equal to 500. It's important to always check that whatever solution you get to a logarithmic equation is actually a valid input in the original equation. 500, if I plug it in there, I have a log of 500. That's a valid input because I can only do logarithms of positive numbers. So there's our solution for part A. For part B, I've got both sides have logarithms now. The left side is already written as a single logarithm, so I'm not going to mess around with that. But the right side, I can combine. I'm subtracting those two logarithms, so to combine those, we divide. We have x minus 2 over x plus 2. Now I can use the one-to-one property of the logarithm. I have the log of 8 on the left and a log base 8 on the right. I can cancel those out and just set the inputs equal. So x minus 1 equals x minus 2 over x plus 2. Okay, now we'd like to solve for x. Now this is just a basic rational equation. If I multiply both sides by x plus 2, x plus 2, it cancels over here. And then I can multiply everything out over here on the left. That gives me an x squared plus x minus 2. Okay, equals, on the right, I just have the x minus 2. Well, now if I subtract x from both sides, cancels everything out there. And if I add 2 to both sides, cancels everything out. And I get x squared equals 0. Taking the square root, we get x equals 0. Again, because we have a logarithmic equation, we want to make sure this is a valid input. Note that if I plug 0 into my original equation, I would have a log base 8 of negative 1. That's not okay. We're only allowed to do logarithms of positive numbers. So since 0 would give me a negative input right here, and right here actually, it is not a valid solution. So this is what we call an extraneous solution. Extraneous solution, which is not actually a solution at all. So we have no solution.